The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All right, so today we're going to wrap up this chapter. We're going to look at section 6.8. The assignment tonight will be 6.8 as well as the chapter review. Tomorrow, Friday, during class, we will go over questions from 6.8 in the chapter review. And then Monday, you will have your first chapter test. On Monday, there won't be an actual class Zoom meeting. You will just take your test, and it's due by Monday night at 11:59 p.m. In fact, you can take the test anytime you want up until then. You can take it Saturday afternoon or Sunday or Monday, but just make sure that you have amount of time blocked aside where you don't have to deal with kids or bosses or whatever, or phones or anything. Anyway, so before we get on to section 6.8, I believe we had a question. And what was it, Kristen?
It was AE plus BF plus AF plus BE.
So is it AE plus EF or BF?
BF, B as in boy.
Okay, BF plus
AF plus BE.
Plus BE.
Yep.
Okay, so I can see the problem right away. Looking at it, there's no greatest common factor for all four terms. And if we split it up the traditional way, the first two and the second two, it isn't going to work. So what we're going to have to do is change the order of a couple of terms. And I think if we just switch the second and the third term, let's see what happens. AE plus AF plus BF plus BE. If we do that, then the greatest common factor of the first two terms is A, and the leftovers are E plus F. So over here, I'd have to have E plus F as the leftovers. Well, things kind of work out. If we put a plus B here, I get the same thing as up there, but the terms have switched their orders, and that's okay. I suppose if you wanted to really make it look awesome, you'd say AE plus AF plus BE plus BF. So switch those around as well. Recall that addition is commutative. So I can take those four original terms and rearrange them any way I want. Doing it this way, now things work out quite nicely. A times the quantity E plus F plus B times the quantity E plus F, which gives me E plus F times A plus B. E plus F. So factoring by grouping, but we had to do a little rearranging of the terms to make things work out nicely. We okay with that?
Yep, thank you.
Any other questions from you or Taylor or anyone that I don't see there?
Would the first one you did, would that one have worked too?
This one here?
No, the one below that.
This?
Yeah.
Yeah, that would have given me the same answer. The only reason I rewrote this is because this isn't an exact match of that, but you could still think of these two being turned around. Yeah, so you'd still end up with this answer.
So both of them would have been correct in WebAssign?
Yeah, well, all you're going to actually show in WebAssign is the final answer.
Oh, okay.
So E plus F times A plus B, or it could have been A plus B times E plus F. Okay. The point being with this problem, sometimes you need to rearrange those terms to get things to work out nicely, is all. All right, anything else? Well, then let's go ahead and go on to 6.8. And what we're going to do now, so we've learned how to solve second degree equations by using the A times B equals 0 or the zero factor property. We're going to apply those to some application problems. Okay, this first one, it's a geometry problem, and it talks about a flag. It says the length of the flag of Australia is twice as long as the width. So I'm going to just draw a flag here, a sad looking flag. Okay. I'm not an artist, except maybe a con artist. So we've got this flag and it says the length is twice the width. So if this is the length and this is the width, the length is being compared to the width. If the width is X, the length is twice the width, so the length would be 2X. Are we okay where I got that X and 2X from? Any questions there? All right. It says, find the dimensions of an Australian flag if its area is 18 square feet. All right. So the area of a rectangle is the length times the width. We're told that the area is 18 square feet. So that's equal to the length times the width. Okay. So now I've got 18 equals 2x squared. This is a second degree equation. I want to put everything on one side set equal to 0 on the other side. It doesn't really matter which side is 0 as long as one of the sides is 0. I'm going to put everything on the right so that my leading coefficient will be a positive 2. So I'm going to subtract 18. So I get 0 equals 2x squared minus 18. So now I've got a second degree or quadratic equation that's in standard form. So on the right-hand side, I'm going to factor out the greatest common factor, which is a 2. Then I'm going to factor the binomial, which is the difference of two squares, into x plus 3 times x minus 3. Then I'm going to take each factor that contains a variable and set it equal to 0, and then solve each of those first degree equations. X plus 3 equals 0. I'll subtract 3 from both sides and I get x equals negative 3. X minus 3 equals 0. I'll add 3 to both sides and get x equals positive 3. So I've got those two solutions, x is negative 3 and x is positive 3. Those are solutions to this equation. However, the question was to find the dimensions of the flag. The problem is that if we choose x equals negative 3, we have a flag with negative dimensions. A dimension is a distance, a length or a width, and it can't be negative. So even though this answer is a solution to the equation, it doesn't fit the actual model of the flag. So x equals 3 is the only solution. So this would be 3. 2x would be 6. The only thing we're missing are units. Now, it said that the area was 18 square feet, so each of the dimensions would be feet. So the width is 3 feet, and the length is 6 feet. Any questions about this problem before we go on? All righty. Let's take a look at another problem involving a triangle. It says, sailboats. Refer to the diagram of the sail shown here. And so I'll draw a picture of a sail as best that I can. And so let's see here. This is going to be a right angle. This is called the foot of the sail. And this is called the loof. Okay. And we're told that the area of this sail is 24 square feet. Okay. Now, it says refer to the diagram. The length of the loof, I think that's how you say it, is 3 times the length of the foot. So the length of the loof, is being compared to the length of the foot. So if the foot is x, the loof would be 3 times x. All right. it says find the length of the foot and the length of the loop. So now we've got the area of a triangle, which is 1/2 the base times the height. In this example, the base would be the foot and the height would be the loop. So our equation becomes 24 equals 1/2 times x times 3x. Again, any questions so far? Simplifying the right-hand side of the equation, 24 equals 3/2 x squared. Do you see where I got the 3/2 and the x squared there? Okay. All right. I'm going to put this thing in standard form by subtracting 24 from both sides. And let's see. I have an equation with fractions. I could multiply both sides of the equation by the least common denominator to clear the fractions. In other words, I'm going to multiply both sides by 2. On the left side, 2 times 0 is 0. On the right side, I get 3x squared minus 48. Again, any questions about what I did there to clear the fraction? All right. Now, I'm going to factor out a 3, which is the greatest common factor. Then I've got the difference of 2 squares, x plus 4, x minus 4. Take each factor and set it equal to 0 and solve those first degree equations. So x is -4, x is +4. Now, just like the previous problem, what we're looking for are lengths or distances that can't be negative. So even though x equals -4 would work if we plugged it back into this equation, it doesn't work for the actual dimensions of the sail. So we're going to throw that one out. If x is 4, this would be 12, and this would be 4. And it said the area was 24 square feet, so 12 feet and 4 feet. So the foot is 4 feet, and the loof is 12 feet. Now, a pattern's starting to develop, but be careful. It looks like we're just going to throw out all the negative answers. That's only true when the values we're looking for are lengths, widths, distances, the base, the height of a, something. Also, if we're dealing with time, we can't have negative time. Perhaps some of you are having a negative time right now since this is a math class, but that's a whole different story. All right, anyway, don't do this. I had a student years ago take a test on this chapter, and the very last problem on the test was something like this, and they correctly eliminated the negative answer because it didn't fit the problem, but then something snapped, and they went back through the whole test, and they crossed out all the negative answers, which was a mistake. If you're just, let's say, solving a second degree equation, it's not related to some situation like a distance or a length, and you get negative answers, they're solutions to the equation. It's only in a context where it doesn't fit the actual situation, okay? In fact, I've seen problems where you kept the negative answers and threw out the positive answers. I think it was asking for, 2 negative integers that's product was such and such. Anyway, just be careful with that, all right? Okay, now we're going to look at a third problem, and this says, let's see here, it's a ropes course, and we have this pole. I know, lovely artwork, isn't it? And let me get a little bit higher. Let's see here. Then we've got this support cable that comes down. Let's make that support cable blue. Okay. And then there's a peg right here. And there's a rope going over here. Okay. And we're told, let's see here, this distance right here is 8 yards. And this distance right here is 6 yards. All right. And this is a right angle. Let me read it to you. It says, a builder of a high ropes adventure course wants to secure a pole by attaching a support cable from the anchor stake 8 yards from its base to a point 6 yards up the pole. How long should the cable be? So basically what we've got is this, okay? We have a triangle. It's a right triangle. This distance is 8 yards. This distance is 6 yards. And this distance, we don't know. Okay, that's going to be our cable. All right. Any questions about the picture or what we're trying to find? Now, this is a right triangle. It is a triangle, but we're not trying to find the area of the triangle. We're trying to find the length of the third side of that triangle, okay? We know the length of two sides, 6 yards and 8 yards. We're trying to find the length of that third side, which represents the cable. With a right triangle, there is a formula that says a squared plus b squared equals c squared. This is known as the Pythagorean theorem. It was created by an early mathematician named Pythagoras. And A, B, and C refer to the three sides of the triangle. C is known as the hypotenuse. I didn't make that up, okay? And C is always the longest side. Can you see that the side we're trying to find, X, that is the longest side. In fact, it's across from the right angle. So this is going to be C. It's called the hypotenuse. The other two sides are referred to as the legs of the triangle. And one of those is A and the other is B. Since addition is commutative, it doesn't matter which leg we call A and which leg we call B. What does matter is that C is the longest side or the hypotenuse. Okay, now taking the information that's given, we have the following. A squared is 6 squared. B squared is 8 squared. C squared would be X squared. Okay. So now we've got 36 plus 64 equals X squared. 36 plus 64 is 100. 100 equals X squared. So we have a second degree equation. We know this because X squared, the highest power of the variable, is 2. We're going to put this in standard form. I'm going to put 0 on the left. So I'm going to get 0 equals X squared minus 100. Any questions before we go on? All righty. So on the right side of this equation, there's no greatest common factor, but I see that it's the difference of two squares, X plus 10 times X minus 10. So now that it's factored completely, I'll take each factor that contains a variable and set it equal to 0, and then solve each of those first degree equations. The first equation, subtract 10 from both sides, X is negative 10. The second equation, add 10 to both sides, X is positive 10. Once again, X is a distance, so X can't be negative. X is 10 and the units are yards. So let's see, the question said, how long should the cable be? The cable is 10 yards long. And you could just say 10 yards. All right, any questions about that problem? Okay, we'll take a look at another situation here. And I'll draw this. Let's see, we've got the ground. And we've got part of a tree trunk. And it broke. You can see why I don't teach art class. Let's see, that actually needs to be down on the ground, doesn't it there? Okay. And what else have we got? Let's see. We know that this is a right angle. I'm going to label some things here and then I'll walk you through it. Okay. So this is X feet. This is X plus 4 feet. And this is X plus 2 feet. All right, this is what it says. A tree was blown over in a windstorm. Find X. Then find the height of the tree when it was standing upright. All right, so we've got this tree where it broke at the trunk, but it forms this right triangle. So the right triangle is right there, okay? So using a squared plus b squared equals a squared plus b squared equals c squared. Now, before I go on, why am I not using a equals 1/2 bh? Because they're going to ask us to find the lengths of the sides, not the area. If it's involving the area, then we would use that other formula, a equals 1/2 bh. But because we're dealing with the lengths of the three sides, that's why we're using the Pythagorean theorem. All right. And it has these three sides labeled. So this is x, x plus 4, x plus 2. The longest side would be the x plus 4. So that's C. The other sides are going to be A and B respectively. And again, it doesn't matter which of the two legs is A and which one is B. So now I've got A squared, which is x squared, plus b squared, which is x plus 2 squared, equals c squared, which is x plus 4, the quantity squared. Now, here's where we've got to be really careful and not make a common mistake. X squared is x squared. X plus 2, the quantity squared, is not x squared plus 2 squared. We have to expand it. X plus 2 times x plus 2. And then in the next step, we'll FOIL those together. This is x plus 4, x plus 4. So now I'm going to get x squared plus x squared plus 2x plus 2x plus 4 equals x squared plus 4x plus 4x plus 16. Any questions about what I did there? Okay, combining like terms, on the left side of the equation, we get 2x squared plus 4x plus 4 equals x squared plus 8x plus 16. I can see that this is a second degree equation, so I want to put everything on one side of the equation set equal to 0 on the other side of the equation. But it's nice to have your leading coefficient on the non-zero side of the equation, to have that leading coefficient positive. If I subtract 2x squared from both sides, on the right side I'll have negative x squared. So instead I'm going to move everything to the left side. I'm going to subtract x squared from both sides. I'm going to subtract 8x from both sides, and I'm going to subtract 16 from both sides. What that gives me is x squared minus 4x minus 12 equals 0. 2x squared minus x squared is 1x squared, 4x minus 8x is minus 4x, and 4 minus 16 is 12. And on the right side, everything cancels out. So now I've got a second-degree equation in standard form. Okay? There's no greatest common factor. The leading coefficient is a 1. It's not a perfect square, so we've got x and x. The product is negative 12 and the sum is negative 4. How about negative 6 and 2? Can that do it? So take each factor that contains a variable, set it equal to 0 and solve it. X minus 6 equals 0. Add 6 to both sides. X equals 6. X plus 2 equals 0. Subtract 2 from both sides. X equals negative 2. And again, we're looking for lengths or distances. So the x equals negative 2 is not going to be a valid solution for the tree. Okay? It would work in the equation, but not for the actual tree. Now, if x is 6, then this distance would be 6 feet. This distance would be 6 plus 4, which is 10 feet. And this distance, which is the distance along the ground, would be 6 plus 2 is 8 feet. But the question said, find the height of the tree when it was standing upright. So we want this piece plus that piece. 6 plus 10 is 16 feet. Okay? So be sure to answer the actual question. We found out what x was, but we needed to find the total height of the tree, which was 2 of the dimensions of the triangle. All right, be okay with this one. Okay, let's take a look at another example then. Let's see here. This says, it says find x, the height of a landing ramp. So we have a skateboarding ramp, and let's see what that looks like. So we've got this picture here, and then here's the landing ramp. And we're told that this is x. This is 17 feet. This is 15 feet. There's your right angle. And then we've got this skateboarder. I'm going to do a very terrible job of drawing a skateboarder. So we'll just pretend that that's the skateboarder. I know, it's pretty sad. It says find x. So again, what are we dealing with here? Well, we've got this triangle. It's a right triangle. This is x, this is 17 feet, and this is 15 feet. Okay? So using a squared plus b squared equals c squared, c would be the 17 feet because that's the longest side. The other two will say this is a and this is b. Okay? So a squared becomes x squared plus b squared is 15 squared equals c squared, which is 17 squared. So then we get x squared plus 15 squared, I believe, is 225. And I think 17 squared is 289. Let's see, 17 squared, yeah, 289. All right. Any questions yet? So I'm going to put this in standard form. I'm going to subtract 289 from both sides, x squared minus, let's see, what's 225? 225 minus 289 is minus 64. So then we've got the difference of two squares again. So if x plus 8 equals 0, then subtracting 8, x equals negative 8. If x minus 8 equals 0, adding x equals 8. Again, it's a distance, yada, yada, yada. We cross out the negative. X is 8 feet. And it just said, find x, so 8 feet. I'm sure you've all seen that cartoon where the question says find x and somebody circles it and says right here. Yeah, well, they actually want a value for x, which would be 8 feet. Okay. Let's see here. We have another situation where we've got, it's a part of the teeth of a pruning saw, and I'm just going to draw the actual triangle. What it looks like is that's supposed to be the right angle. We're told that this is x plus 1, and this is x plus 2. And it says that the dimensions are in millimeters. Okay. So using a squared plus b squared equals c squared, the hypotenuse would be that. So we'll call this a and that b. So we've got x squared plus the quantity x plus 1 squared equals the quantity x plus 2 squared. So this is very much like the problem we did earlier, where now we've got x squared plus x plus 1 times x plus 1 equals x plus 2 times x plus 2, which gives us x squared plus, foiling, x squared plus 1x plus 1x plus 1 equals x squared plus 2x plus 2x plus 4. Combining like terms, on the left side, we get 2x squared plus 2x plus 1, putting those together and those together. On the right side, x squared plus 4x plus 4. Just like before, I'm going to move everything to the left side of the equation so that my leading coefficient is going to be a positive 1. So I'm going to subtract x squared from both sides. I'm going to subtract 4x from both sides and subtract 4 from both sides. I get x squared minus 2x minus 3 equals 0. Factoring, I get an x and a minus 3 and a plus 1. Okay. So then x equals 3, x equals -1, right? And again, we throw out the negative because we're dealing with distances. So let's see, this would be 3 millimeters. This would be 3 plus 1, which is 4 millimeters. 3 plus 2 is 5 millimeters. So the lengths of the blade, 3 millimeters, 4 millimeters, and 5 millimeters. Any questions about that problem? Okay. Well, here's another situation. Let's talk about integers. What are integers? Coming from the left, -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, etc. So those are integers, whole numbers and their opposites, all right? Consecutive integers would be one right after the other. So -7, -6, -5, -4. Those are consecutive integers, okay? Now, so consecutive integers. Let's say that I started with this one and called it x. So the first consecutive integer would be x. What would the next consecutive integer be? Wouldn't it be one more? So it'd be x plus 1, and the third would be x plus 2, etc. So 3 consecutive integers would be x, x plus 1, x plus 2. Does that make sense? Any questions there? Okay, let's talk about consecutive even integers. So if this is the first one, the second one would be x plus 2, and the third one would be x plus 4, because consecutive even integers go up by 2s. Are we okay with that? All right, let's talk about consecutive odd integers. First, second, third. How about this one? Let's say we call that x. What would the next consecutive odd integer be? It would also be x plus 2, and the next one x plus 4. So if this is x, because consecutive odds go up by 2s, just like consecutive evens go up by 2s. Somebody gets confused and they say, well, how can x plus 2 be odd when 2 is even? But if you have an odd number x plus 2, you still have an odd number. So if this is odd, these will all be odd, the next consecutive odds. Okay? Any question about that information? All right, now it says the car numbers of drivers Casey Kane and Scott Riggs are consecutive positive integers whose product is 90. If Kane's car number is the smaller, what is the number of each car? All right, so we've got Kane's, let's see, that's an H, Kane's car number, and Riggs car number. It says that they are consecutive positive integers. So if they're not consecutive odds or evens, they're just positive. So one of them's x, the next would be x plus 1. It says Kane's is the smaller number. So this would be x and this would be x plus 1. Are we okay with that? All right. It says they're consecutive positive integers whose product is 90. So our equation becomes, whoops, x squared plus x equals 90. Subtract 90 from both sides of the equation. X squared plus x minus 90 equals 0. That's a pretty sad looking x, I'll admit. Factoring. Let's see, we need a product that's negative 90 and a sum that's positive 1. How about 10 and negative 9? Okay. So x is going to be negative 10 and x is going to be positive 9, isn't it? Okay there? Now, again, it said positive integers. I've never seen a sports car or an athlete that had a number that was a negative number. There's a few maybe that should have, but that's another story. So again, we throw out the negative. X is 9, x plus 1 is 10. So what is the number of each car? Kane's is 9 and Riggs is 10. All righty. Any questions about that? Well, that's all I've got for you today. So I'm going to go ahead and stop the recording.